Hello students, welcome to your second video on solving quadratic equations. In our first video we were solving quadratic equations just by graphing and viewing x-intercepts on the graph. In this lesson we'll be solving quadratic equations by factoring. So our learning target is I can solve quadratic equations by factoring.
Mommy, that's the first movie!
So what is a solution of a quadratic equation? We've talked about these four words quite a bit, and in our first video we focused on the word x-intercept, that anywhere a quadratic graph or a parabola crosses through an x-axis is a real solution to a quadratic equation. So these are real solutions, but we can also find solutions to a quadratic equation by factoring. And remember, we can use the word solution, the word zero, or root to mean the solutions of a quadratic equation. This is a property that really enables us to solve any quadratic equation by factoring. It's called the zero product property, and it's really important. The zero product property says that if I multiply any two factors together and 0 is the product, well, how do I multiply and get 0 for an answer? What do I multiply in order to get 0 for an answer? Well, the answer is, if I multiply two factors together and the product is 0, then either that first factor A or that second factor B had to be a 0. The only way we multiply and get 0 for an answer is multiply by 0. So we multiply by a 0 to get a 0 product. Okay, so the only way that we get a 0 for a product is by multiplying by a 0. That is important to every part of solving this equation by factoring. So in our first example, it says, what are the solutions of x squared minus 5x plus 6? Well, first of all, this is a trinomial, and we are going to factor this using a chart method. So we're going to list the factors of 6. That will give us a sum of the middle term, negative 5. So what are factors of 6? Well, I know I can multiply 1 and 6. I know I can multiply 2 and 3. 1 and 6 adds to be 7. 2 and 3 adds to be 5. But I need my sum to equal negative 5. Since it's factors of a positive, I know that a negative times a negative would still equal a positive number. So negative 2 times negative 3 would multiply to be positive 6. But if I add negative 2 plus negative 3, then that would equal negative 5, the sum that I was looking for. So this particular trinomial factors into the factors x minus 2 times x minus 3. And it is set equal to 0. So the zero product property tells us that if I multiply this first factor times this second factor and my product is a 0, then one of those factors has to be a 0, or both of them could be. And since both of them contain a variable, either one of them could actually equal 0. So we're going to set each factor equal to 0, because either of them equaling a 0 makes this equation true. So solving the first one, we're going to add 2 to both sides, and that gives me a solution of x equals 2. The second one, I'm going to add a 3 to both sides, and that gives me solution of x equals 3. So the solutions to this quadratic equation are 2 and also 3. Do you know what that means graphically speaking? Graphically speaking, if I were to go to the calculator and graph this, or go to graph paper and graph it, then at positive 2 and at positive 3, this particular parabola is going to cross through the x-axis those two places. And it smiles because it was positive in the front. So there is just a look at a sketch of what this graph would look like. So we could solve by graphing, but now we're learning a second method. We can solve by factoring. So we get the solutions 2 and 3, and this is a way of solving without having to graph. In the second example, it is again asking us to find the solutions of the quadratic equation, and we are going to approach this by factoring. Now, something that I didn't say in example 1, because it didn't affect that example, is that we cannot solve by factoring until we set the equation equal to 0. Why is that? We can't use our zero product property if we don't have a product of 0. So, step 1, every time, if you're solving by factoring, is going to be to set the problem, set the equation equal to 0. Well, the only way I can set this equal to 0 is to somehow cancel out this negative 12 here. So this negative 12 could be canceled with its additive inverse, which is positive 12. So I'm going to add 12 to both sides of the equation to keep it balanced. And that gives me a 0 on the right side. That's what I was looking for. And again, this 0 is going to enable me to use the zero product property. On the left side, I don't have any like terms. So I'm just going to bring all the terms down. X squared minus 7x plus 12. So at this point, we're ready to factor. We're going to create a chart listing the factors of positive 12. So we're listing the factors of 12 that will give us a sum of negative 7. So here, our factors of 12 I know are 1 and 12. I know 2 and 6. I know 3 and 4. And that is a complete list of factors. And I want the sum to be negative. So again, this time I'm looking for negative factors that multiply to be a positive and add to be a negative. So they're going to need to all be negatives. But I'm looking for the sum that will be negative 7, which is going to give me a winner at negative 3 and negative 4. So that means I'm going to factor into two binomials of x minus 3 and x minus 4. Now, according to the zero product property, which I can now use, if I have one factor multiplied by a second factor, and the product of those two factors is 0, then that means that either of those factors could have equaled 0. And since they both contain a variable, we set both of them equal to 0. So, I'm going to add a 3 on both sides. Oops, undo that. Okay, I'm going to add a 3 on both sides here. And I get x equals positive 3. Add a 4 on both sides here, and I get x equals positive 4. So I have two solutions, x equals 3 and also x equals 4. I could write the solution set 3 and 4, separating with a comma. Or that would mean that graphically speaking, that would mean graphically speaking, this particular parabola is going to cross through the x-axis at positive 3 and also at positive 4. And it is smiling. So I could have solved by graphing, looking at those x-intercepts, or without graphing, we can solve using factoring and the zero product property. So in example 3, what are the zeros of the quadratic function? This puts our quadratic equation in function notation when we use f of x, but I don't want you to be intimidated by that. When you see an f of x, it's really just a fancy way to say y. Y equals x squared minus 3x minus 28. And in order to solve a quadratic equation by graphing, the first step is to set the equation equal to 0. So if it's set equal to f of x, or if it's set equal to y, you can change that to a 0. That is because we want to use our zero product property. Okay, so now that we have our equation set equal to 0, we're ready to factor. So factors of negative 28 that add to be negative 3. Take a moment, list the factors on your own, and see if you can come up with the factors that multiply to be negative 28 but add to be negative 3. Pause the video. So here's a look at the factors, all of the factors of negative 28. Remember that when you're factoring a negative number, we get really a duplicate of all the factors because the negative could go on either term. But then we were looking for a sum of negative 3. So we go down here to positive 4 and negative 7. There's our winners. So when we factor this, we're going to factor into two binomials set equal to 0. The first factor is going to be x plus 4, and the second factor is going to be x minus 7. Now remember, the order in which I put those doesn't really make a difference, but I have to be sure that the 4 has a plus sign with it and that the 7 has a minus sign with it. Now we're ready to solve. If I've got these two factors multiplied together and we say that those two factors equal 0, zero product property says that x plus 4 could equal 0 and x minus 7 could also equal 0. So we're going to solve each of these. So subtracting 4 on both sides, I get one solution of negative 4. Adding 7 on both sides, I get a second solution of positive 7. So here we have two solutions, negative 4 and positive 7. Those would also be two real x-intercepts, two real solutions. That would also be the x-intercepts of the graph. Example 4 is just a little bit different. It asks us to calculate the roots of the quadratic function. Remember, roots is the same thing as a solution. This is given in function notation. To use the zero product property, I need to replace that with a 0. Negative 2x squared minus 24x. Now, this particular quadratic equation is not a trinomial. I don't have three terms, but you should see that in the two terms that are here, we have a GCF. So I could say that the numbers 2 and 24 both have a 2 in common, and since they're both negative, I'm going to factor out a GCF of negative 2. And I can also say that they both have an x in common. Both terms have an x. So if I factor out negative 2x, that's like dividing by negative 2x. Negative 2x squared divided by negative 2x, well, negative 2 divided by negative 2 is positive 1. Subtract the exponents in division. 2 minus 1 leaves me x to the first power. Then negative 24 divided by negative 2 gives me positive 12. And subtracting exponents, x to the first power, subtract 1, the x's are gone. So this is my factored problem. So now when I use my zero product property, here's my first factor, here is my second factor. So the zero product property says if I've got this equal to 0, then one of these factors has to equal 0. It could be either 1, since they both contain x. So we'll set each factor, negative 2x, equal to 0, and x plus 12 equal to 0. Solving these, the first one In order to get the x alone, negative 2 is being multiplied by x, so we divide by negative 2 on both sides. So x is going to equal 0. On the second one, we subtract 12. So x is going to equal negative 12. So again, we're coming up with two real solutions of 0 and negative 12. So here's example 6. The directions are just to solve. I know that this is a quadratic equation because the highest exponent in this equation is the second power. So that's my clue that this is quadratic. And we're going to attempt to solve this by factoring. So to begin, we want there to be a 0 on one side of the equal sign. So I want to cancel out this positive 2 with its additive inverse, negative 2. And what I do to one side of an equation, I will do to the other. So I'm going to subtract 2 on both sides. Also, I want this negative 2x to cancel. So to cancel it, I'm going to add 2x to both sides. Notice how I'm lining this up under the terms that they will actually combine with. So 5x squared just comes down. 30x and 2x combine to be 32x. And 14 plus negative 2 adds to be 12. Now on the right side, the 2 and minus 2 cancels, negative 2x and plus 2x cancels, it's equal to 0. Now when I take a look at this looks different than anything I've factored so far in this lesson. This is going to have to be factored by a different method. We've got a trinomial, but there's a leading coefficient in front of x squared. So I can't just factor this with a regular chart. I'm going to have to factor this using the AC method. So the AC method says take A, the first term, and C, the last term, the last term and the first coefficient, and multiply them together. 5 times 12. Hence A times C. Well, 5 times 12 is 60. So we're going to list the factors of 60 that will give me a sum of my middle term, 32. It's fairly easy to recognize 2 times 30 equals 60, but adds to be 32. Okay, so 2 and 30 are the factors. Now, when we're factoring by the AC method, I'm not going straight to binomials here. I'm going to create a polynomial of 4 terms. So I'm going to keep my 5x squared at the front. I'm going to keep my plus 12 at the end. But those two middle terms are going to be plus 2x and plus 30x because 30x and 2x combine to be this 32 here. So I've written this as a polynomial of 4 terms, still set equal to 0. Now, once you write it as a polynomial of 4 terms, you're going to group the first 2 together and group the last 2 together. And what we're going to do to factor this is look for a GCF in each group. So in the first group, 5 and 2 don't have a common factor, but both terms contain x, so I can factor out x, leaving me with 5x plus 2. In the second group, 30 and 12 have a common factor of 6. 6 is in common. 30 divided by 6 leaves me with 5x. 12 divided by 6 is 2. And that's all set equal to 0. Now, when we factor by grouping, we're looking at group 1, group 1, and group 2. And if you look carefully, group 1 and 2 have something in common. They have this binomial 5x plus 2 as a common factor. So we have another common factor that can now be factored out. So I'm going to say that 5x plus 2 as a binomial gets factored out here and here, leaving me with leftovers of x in the first group and plus 6 in the second group. So now my binomial is completely factored into the terms 5x plus 2 times x plus 6. go back to the zero product property. If I multiply those together and get 0, that means 5x plus 2 could equal 0. Also, x plus 6 could equal 0. So I'm going to get my two solutions by subtracting 2 on both sides here. 5x equals negative 2. To get x alone, then I'm going to divide by 5. So x would equal negative 2/5. Subtract 6 on both sides here. X equals negative 6. So I've got two solutions, two real solutions, negative 2/5 and negative 6. So I hope this helps you with another method, second method for solving quadratic equations. We now have learned how to solve a quadratic equation and get real solutions by graphing. We also have learned how to solve quadratic equations by factoring. And we've got a couple more methods coming your way soon. So hopefully this helps you understand our lesson, and good luck with your assignment.